We want to determine all intervals on which the graph of f of x equals x squared plus 1 all over x squared minus 4 is concave up or down. So that means I need the second derivative. And because I have variables on top and bottom, I have to go straight for the quotient rule just to get the first derivative. So over here, we'll do low and high, d low, and d high. So both of those derivatives are 2x, right? All right, so we have low d high minus high d low over low low, and that gives us our first derivative. Be really careful here. You cannot reduce an x squared minus 4 because they don't all three have it. If you can't factor it to the front, you can't reduce it. Make sense? But what we can do is take out a 2x. And if I take the 2x out, that leaves me with x squared minus 4, right? Minus x squared minus 1. Because we have to distribute this minus sign to what's left. So for our first derivative, these x squareds cancel, and I'm really just left with 2x times negative 5, which is negative 10x over x squared minus 4, quantity squared. Now that's just my first derivative. We'll have to do the quotient rule again to find the second. So I'll pause for a second and let you see if you can do that on your own. So now that we have the first derivative, we're going to do the quotient rule again and try to find the second derivative. Okay. So if we do low d high, we have negative 10 times x squared minus 4 quantity squared. Minus high d low, which will become a positive 40x squared times x squared minus 4 all over low low again, which is x squared minus 4 to the 4th. Now in this case, I can take out an x squared minus 4 and reduce it, right you guys?
Yes, ma'am.
Yes? Okay. So do you want to take out a positive 10 or a negative 10?
Negative.
Negative?
Negative.
Okay. You try to take out a negative 10?
Yeah.
Alright, let's see what we get.
Dang.
We're going to take out a negative 10 and an x squared minus 4 to the first power. That will open up a bracket and give us one of these left. And then we took out a negative 10, so we have a negative 4x squared left. Double check there. All over x squared minus 4 to the 4th power. So now we can simplify one of these guys down to the 3rd power. It looks like our final derivative will be negative 10 times, what is that, negative 4 minus 3x squared? It's a lot of negatives, but that's okay. All over x squared minus 4 to the 3rd. So we're going to pause, and I want everybody to double check and see if we made any mistakes. And then we'll make a number line test. Okay, so now we want to set the top and bottom equal to 0. So we have negative 10 times negative 4 minus 3x squared equals 0. So divide both sides by negative 10, and we have negative 4 minus 3x squared equals 0. So negative 3x squared equals 4, x squared equals negative 4/3, and those are going to be imaginary, so we're not going to worry about those. Now we'll set the denominator equal to 0. Take the cube root of both sides. So how about plus or minus 2? And that makes sense because if we look back at the original problem, those are going to be vertical asymptotes, right? So they should always show up in your derivatives as critical numbers. Okay, so we'll make our number line. And we have negative 2 and positive 2. We'll substitute into the second derivative to check ourselves to see where they're positive and where they are negative. So I took negative 3 and substituted into the second derivative, and I got positive 62 over 25.
Same.
When I plugged in 0 to the second derivative, I got negative 5/8.
Same.
And when I plugged 4 into, I don't know why I did 4. I guess I could have done 3, but I got another positive.
Same.
All right, that's great. So it looks like we have 2 intervals where it's concave up and one where it's concave down. So let's take a look. So if I wanted to check myself, what could I do? I could look at the graph of the what? Original. So if we go to y equals, we look at the graph of the original. Let's take a minute and just kind of get a look at it. So when we actually graph it, let's see if we can pull it up. This is what we get. So we can see that this piece right here from negative infinity over until we hit that vertical asymptote at negative 2 is concave up, right? And then on the other side of the vertical asymptote, it's also concave up. But in between the two, negative 2 and 2, we have a piece that's concave down. So you can always check your work by looking at the original graph. So now we're going to find the points of inflection and talk about the concavity, but this is a much easier graph because it's a polynomial and we just have to use the power rule, not the quotient rule. So we have f of x equals x to the 4th minus 4x cubed. And if I take the first derivative, what do I get?
4x third minus 12x squared.
4x cubed minus 12x squared. And then I'm not going to stop there. I need to take the second derivative. So that gives me 12x squared minus 24x. Is that okay, you guys?
Yep.
Okay, so now I just need to factor it, set it equal to 0. It doesn't have a denominator. So I can take out a 12 and an x. And that's going to leave me with x minus 2. Is that right? So it looks like I have 2 critical numbers for the second derivative at 0 and positive 2. And that's where you're going to break your number line. So we'll just pick some numbers, say negative 1, positive 1, and 3, and substitute them into the second derivative. And it doesn't matter if you substitute before or after you factor. And see whether it's concave up or down at those spots. So when I substituted in negative 1, I got positive 36.
Yes, ma'am.
When I substituted in positive 1, I got negative 12. And when I substituted positive 3 into my second derivative, I got positive. So it looks like it's concave up from negative infinity to 0 and from 2 to infinity, but concave down between 0 and 2. And there appear to be 2 inflection points, which was the first thing we were asked to find, or points of inflection. We'll just abbreviate those IP. So it looks like one's happening at 0 and at 2. And how do I find the y values for those? Into the original, right. So if I plug 0 into the original, what do I get? I get 0, 0. And how about 2? What happens if we plug 2 into the original?
Negative 16.
Did you guys get negative 16? Perfect. Those are the inflection points. Now I'll go ahead and list the concavity here, since it did ask us to discuss it. And you should be able to look at the graph of the original to verify those things. Now you may have to play around with your window range a little, because if we're going to see 2, -16, we're going to have to zoom out a little bit. But you should be able to see where the concavity is changing there.